Okay, once again, I apologize. My 4 minutes were up. So that's position. Okay. And the last sort of distance quantity that we're going to learn about is kind of the weirdest one. And it's called displacement. Okay? And the definition of displacement is the change in position of an object. Okay? So, for example, here's my number line, my imagining number line. Okay? And I start here and I end here. Okay? Start, and end. Okay? The displacement is the change in position. And the way we represent that is the final position minus the initial position. So I would say, I would represent my final position, my ending position, with x sub f, and my initial position with x sub I, initial and final. And if I subtract those two things, what I get is the displacement. Okay, and in this case, it's your final minus your initial. So 1 minus -1, which is 2. My displacement is in the positive direction, and it's 2. I have moved positively by 2 meters, start to end. All right. Now, for the variable for displacement, we actually don't write this out every single time, x final minus x initial. We use something that's sort of shorthand for that. And that is the Greek letter capital delta over there, delta x. And in general, we're going to use delta a lot this year. And delta means change in anything. Okay, so delta x is change in position. And so what this literally means is x final minus x initial. Okay? Another example, let's say on this imaginary one-dimensional number line, don't worry, we're not doing 2 dimensions yet. Let's say this is my initial position, and -3 is my final position. My displacement is going to be my final minus my initial, which is -8 meters. I have moved in the negative direction by 8 meters. Okay, notice the sign tells you which direction you've gone. And that makes this type of quantity also a vector. Okay, because direction matters. A vector means direction matters. And that's for now all you need to know about vectors. And the units, again, it's still a distance quantity, so it's going to be